Okay, when I introduce algebra tiles, I first show them just a basic slide explaining what the algebra tiles mean. And so I show them this and I say, okay, well, here's x squared, here's x, and here's 1. And I show them what the pieces mean too. So for example, 1 is called 1 because this distance, so this length and this width, are both 1, and 1 times 1 gives an area of 1. X is called x because this is a length of 1 and this is a width of x. X times 1 is x. This is x squared because this is the length of x, this is the length of x, so x times x gives you x squared. Now the negatives don't work as much with the description of the like the distances because you don't have a negative distance, but we do need negative numbers, so I just explained to the students that's why we have those. So then after that I go into something like this where it just says to represent the following with algebra tiles. I show them really quickly that 2 just means you have 2 ones. And that should be very familiar to them actually from stuff they did in elementary school. And then I go into 2x and I start talking about, okay, so what does 2x mean? Well, then I talk about why is this x here? What does an x look like? Well, we just discussed that an x looks like this piece. So x is the type of shape that we have, or then I introduce the word term. X is the term that we have. This tells us how many of them. So we have 2 x's. So I show them that looks like this. And then I give them maybe an example to do on their own. And then I have them try this example. Now some of them will get confused because of the x squared and not be sure what to do with the squared part. But I just go in and I show them that, okay, well, when we saw this one back here, we knew that this x was a type of piece or a term that we had. So then I would go and say, okay, well, this x squared is also a term or a shape or a piece that we have, and that's what it looks like. The 4 tells us that we have 4 of them. So then I would describe, well, these two terms, or this term is different from the 2x that we saw earlier, and what's making them different is not the x, but it's the exponent. So the fact that it has an exponent is actually changing what this shape looks like. So it's no longer the same type of shape or not the same term. So we're starting to get into that terminology and that mathematical vocabulary. Then I go into something like this just to show them that negative would be the red pieces. So this tells us we have 2 1s, but because it says negative, that means they're red this time. And then I get into something like this. And with this problem, I would probably do an I do just to introduce it to them, just to show them what does the plus mean, how does this look. So I'd say, okay, well, this has an x. Now it doesn't tell me how many x's, but it does say that I have an x. And then this might be a good time to introduce or remind students that just because there's not a number here doesn't mean it doesn't exist. There's actually a 1 there, which is, we don't write it because there is an x, so we don't have to say how many there are. We can see that there is 1 of them. And then I would move on and say, okay, well, I'm not sure what this plus sign is indicating, except in math I know that plus means to add in something or in addition to. So I think this means in addition to the x that I have, I also need a 1. So I'm going to put a 1. And then in addition to the 1 and the x, I also need 2x squareds. So then I talk about how addition is actually just showing us what we have represented here. We have an x, a 1, and 2x squareds represented all on our algebra tile map. And it may even be something you would want to show that usually our final answer is written where we have our largest pieces, then our next largest, then our smallest. So the best answer to write is 2x squared plus x plus 1, and that's called standard form. I don't know if that's a little bit more than what you guys are required to do in 7th grade. I'm not sure, or at this time, but it wouldn't hurt to mention now. Then I would give them something like this and have them try it out for themselves, kind of walk around the room and see where they are. And then I would say, okay, let's write the following representations. So for example, basically we've seen a lot of the numbers and we've represented it. Let's do it the other way around. So I'd go in here and I'd say, okay, so I know that this is x and there's 2 of them, so I would write out, let me do that. I would write out 2x, and then there's 3 1s, so I'd write 3, and then I said, oh, I remember I have to say that I'm adding those together because I want to represent everything being brought together on my algebra tile map. And then, let's see, then I would just go on. to this, so throwing in the negative, so negative x plus 1. Go on to something like this, just looking at the different types of pieces, throwing in some negatives so they're comfortable with it. And then this is where I would get into starting to combine like terms, but specifically looking at something called zero pairs. So here we would see that we had 2, and here we would see we have negative 3. And then we could talk about that's either 2 plus a negative 3 or 2 minus 3. And however you guys have discussed that in the past, students will know that that should be negative 1. But the way that we're going to show that, because I don't see negative 1 represented here, so what we're going to do is we're actually going to look a little deeper at this. And we're going to say, okay, well, let's kind of group these together because they're the same type of shape, they're just 2 different colors. So let me look at one of each color individually. So notice that this is a 1 and this is a negative 1. Well, if I have 1 of something and I have a negative 1 of something, that would those two things actually add to give me 0. And these are called zero pairs. So I try with my students, I call them zero pairs, and then from here on we call this adds to 0 or makes 0 pairs. I try really hard not to say the word cancel just because we use cancels a lot in math and we use it for a lot of different things and students get confused about what it actually means. So in this instance I try to say adds to 0, so those two add to 0. And then that happens again. My students are also able to tell me that I have 2 zero pairs here is what happened, and that's where our negative 1 comes from. So this idea takes a little bit of time for the kids to grasp, but once they get it, it's really quick. It just takes them a little bit of time. So then I show them how it works with different shapes. So I would write negative x plus 2x. I would show them what it looks like with the zero pairs, and then I would also kind of start to show them how it's working with the numbers, not give them too much information, but just let them start noticing some of the patterns. And then I would go in and say, okay, we have 2x squared minus 2x plus 2x, show them how all the x's are gone, so now we don't write any of them, we don't say anything because they're all gone, they all added to 0. And then there's a few more examples if you think your kids need them from there, so I just included a few more in there. And then the next thing I want to do is say, okay, well, we've been looking at a lot of the pictures already given to us. What if it gives this to us as an equation instead, or as an expression instead? So in this case, I have 5x plus 3 minus 2x. So I would go ahead and, since they're just learning it, I would go ahead and represent the tiles with it. So here's my 5x, my plus 3, and my minus 2x. And then I would start talking about, okay, well, let's see what we notice. So I noticed that I've got some red and some blue of the same shape. So I know I'm going to have some things that are going to add to 0. I noticed that this is a totally different shape, so that means it's a different type of term. So that's when I would probably start doing some of that grouping, those grouping ideas. So I would say, okay, well, here are some of these things I can group together. And then I might even go back up here and actually draw some of those ways that we teach grouping, like circling things that are like terms. So showing those two things are like terms, and then showing how I moved them over here, so maybe even talking about, I know that you guys wanted to talk about the properties a little bit, so maybe talking about the commutative property, being able to move things around, or associative property depending on how you're looking at it. So just the different properties that you're using within this, because I think that you guys have been talking about it before. So you can show it not only with the movement of the algebra tiles, but also with the movement of the numbers, and kind of show them how that's related and why you're allowed to move it like that. And then showing them these 0 pairs here. So then notice we're left with 3x, so then I can look up here and say, okay, this says I have 5 x's, and I'm taking away 2 x's, which gives me 3x, which is exactly what's represented. So then moving on to something maybe even more complicated, so I would tell the kids to take it one step at a time, representing every single piece, rearranging the pieces that they have, and combining any like terms that they have, and going from there with just the pieces. And then I would go into maybe something like this and say, well, we don't have a piece that represents y. So in this case, for the kids that still need the support with noticing what's making things like terms, I might say that, okay, well, instead of y, let's put a heart or some other shape. and then just say that this term is called y, and I have 2 of them. Do I have any other terms that are named y? And then I should say no, I don't see any other y's, so I can't combine them with anything because I don't have any other y's. And then I would just give them this as groups and just kind of walk around and see where they are. In the previous problems, I was thinking the ones that looked like this, where they're actually writing out their answers, you could do a show me with that, and that might help you group or pull students for this activity where they would be working all together, just to, I guess if you need a smaller group to work more one-on-one with them, they're just not really getting it. But this one starts out with, I always tell my kids it looks super complicated, but just take it one step at a time, and one term at a time. And then this one has the y that we kind of talked about a little earlier. Now this one's different. So this one has an x and a y in it. And I just wanted to put this in here so that the kids would start talking about, well, what does that mean? What does it look like? Does that mean that we have an x and do we have this rectangle piece and a heart smushed together? Do they make a new shape when they're smushed together? Like, what is it? What happens with that? And just get the kids kind of talking with their groups with that. And then I'd probably bring the class back together to have a discussion about why the xy and the xy, why those are the same type of term, and why x is a different type of term. And then the last piece, I purposefully put like larger numbers in here to try to encourage the students to not have to use the algebra tiles and to get away from it, because nobody wants to represent 27 x's. So what my kids recognize is that there's 27 x's, they can visualize that's a shape. Here's 3 x's, they visualize that's a shape, so in total there's 30 of them. So that's kind of where we want the kids to go with that. So that's pretty much all I would do for that day. I mean, I think that's about as far as you guys wanted to get anyway. You may want to throw some more problems in there. I would say, like, in your practice, continue to try to get them away from the algebra tiles, but still have that support for the students who need it, because I don't think there's anything wrong with them needing that support, but just in your wording, trying to get away from the use of the algebra tiles. And just making up problems like this where it's not useful to have algebra tiles, it just makes it more complicated, and it would just take too long. Or problems like this where they don't have a shape to represent that. The next thing I wanted to show you was, I saw that you had some expanding, which I assumed was like the distributive property. So I wanted to start, I saw in there that it said it had like the area model, but I wanted, if you're going to teach that, use the algebra tiles, which I hope you do, it would be good to show the area model with the algebra tiles before you jump straight into the area model. So I wanted to show you that back in elementary school, the students learned to multiply numbers like 25 times 23 using an area model, and it started back with base 10 blocks. So they would take 25 and split it into 20 and 5, and they would have 2 10s here and 5 1s here. And they'd have their base 10 blocks, and they'd set them up like that, and then they would just fill in the inside with the pieces that fit. Well, then they knew they couldn't use base 10 blocks for the rest of their lives, so they went in and started creating these area models where they split up the 10s and the 1s, and they created their boxes. And then to get the pieces inside the box, they just multiplied, so 20 times 20 to get 400, 20 times 3 to get 60, and then they would add up all these pieces together to get their final total area, because 25 times 23, that's like finding an area because you're multiplying. So they've seen this idea, this area model before, so that's what makes this a little bit nicer, is when you show them something like 2 times 5, so 2 times 5, if you just remind them of the base 10 blocks, all my kids that I have taught over the last 3 years have known what I'm talking about, so I'm assuming they're using that in elementary school. So now they just have to, this is where they have to know how the shapes fit together. So for example, this has to be a 1 because this distance is 1 and this distance is 1. They have to match up, same across the top. So the kids will definitely try to put an X here because they think it looks like it fits, which it kind of does, but just tell them that one of the rules for algebra tiles to work is that they all have to agree that the sides have to match. So across the top here is X, but all that's like 5 ones, and that doesn't match with x. We don't know what x is, and there's no way for us to tell what x is. So just getting the students to see that. So then they'll fill in and see that there's 10 here, and they also know that 2 times 5 is 10. So then 2x could be explained the same way. We have 2 ones across the side. We have x across the top. So we fill in, and this time we can use an x because we have an x distance here, so that's 2 x's. Next is 4x. I'd probably just have them try this one on their own. 4 times x to get 4x. Then I'm moving into starting the distributive property. So notice I wrote it in parentheses just to kind of keep it consistent with what I had written before, but eventually I'm going to get away from writing the parentheses. And then I would just show them the two ones times x plus 4. I would probably do this as a think aloud, kind of thinking through, based on what we've done so far, how to represent each of the sides of this area model. And then filling in the pieces. So this would have to be an x piece because that has to be a 1, that has to be an x. Going from there, putting in all these ones. Usually when I'm at the board, I'm lazy and copy-paste them like this. Okay. Okay, so then showing them that this is now 2x plus 8. And I don't show them any other method yet. I just want them to see what it looks like with the algebra tiles. So then I might have them try this one on their own, kind of see where they are, address any misconceptions that I see at the time, go in and introduce this one now because it's a negative. So putting my -2 here, and then my x and my 1. One of the biggest things the students have to know with algebra tiles is that a negative number times a positive number gives you a negative result. So knowing that that's got to be negative x because this is -1 times positive x, or just a negative number times a positive number. And that will work for all of these. So then we'll have -2x minus 2. And then I also write the answers down here so they can see the numbers and the letters. So I think then at this point I would say, okay, well I don't want to represent these tiles all the time. So let me go back to the first problem we did and show you how we could do this with just writing numbers and not necessarily having to draw or move around tiles. So I would go and I would say, okay, well I know that this side is a 2, across the top is an x and a plus 4. Notice I've written it just as it is in the expression up here. And then I'm going to kind of separate the different shapes here. So I kind of start to show my box like that. Let's see if I can make this bigger, if it'll work. Okay, so I kind of start to show my box like that. And then I say, well, let me do this without all that mess in there. So let me draw us another picture down here, another visual. And then I say, okay, well, let's see how we got what we had. We had 2 x's here in this box. If I did 2 times x, oh, well, that gives me 2x. In this box, I could do 2 times 4, and that gives me 8, which is exactly how many ones I had. Notice that I do add the plus here to the second number just to remind them that this is representing x plus 4. So I think that's personal teacher preference, but it just helps me to remember, or to help them remember, that that's actually an expression across the top. Okay, and then I would go and say, okay, well, with the one that you guys just made, why don't you try drawing the area model based on what the tiles look like? And then we could do one more example, and then get into this where, yes, this is more beneficial to now do the area model and show them that. And then at some point, we would have done enough of these that I would say, okay, well, I'm also starting to notice a pattern that I'm just multiplying that number times each of the terms there. And this is where I would introduce the distributive property and talk about what that looks like and how you would deal with that. And then my biggest thing is I just want the kids to notice the patterns. So even though we've created this box, it's just helping us organize. It's not a new way of doing anything. It's just helping us make sure we keep all of our pieces, just like the distributive property. So I would encourage the students, I would say, okay, well, in the future, when you get into higher math and we get into more equations and solving and stuff in the future, we're going to want to know how to do the distributive property because it's going to be a lot of work to go to the side of our paper all the time and draw this box. So I would encourage that in class, but I would also not want to discourage students who really need this organization, even when they're leaving my class at the end of 8th grade in algebra. If they want to draw the box, then I'm perfectly fine with that if they're efficient at it. That's the goal, is that they be efficient. So that's pretty much it with adding, subtracting, expanding, factoring for what you guys are doing. There's one more thing I wanted to show you. I did notice that you were doing greatest common factor, and I wanted to show you something that I had seen before. So I know that the ultimate goal is that they'd be able to notice the greatest common factor is 10, and then to basically do the distributive property backwards and to pull out a 10. But if they didn't notice that, I've seen this method where you would actually divide by any factor, any common factor. So maybe I noticed that they're both divisible by 5. So I could divide them by 5, be left with 10x plus, 2. Okay, well then I stopped there and I'm like, well, 10 and 2 are both even, so that means they're both also divisible by 2, which leaves 5x plus 1. And then 5 and 1 are not divisible by anything in common besides 1, so I'm done. And then this over here, 5 times 2, that's going to be your greatest common factor. So if you're having kids who are struggling with finding greatest common factor after you've gone and you've listed out all the factors and done all of those things that I saw you're doing in some of your lesson plans, this might be a good thing to give some of those students who are still struggling with finding the largest one, so at least they know that they can get there. It might take them longer because they're not noticing the larger one, but at least they have a chance of finding the larger one. And I also have a really good article that I sent to the 6th grade teachers on finding greatest common factor and being able to do it without listing out all the factors and finding the 2 that are the largest in common. If anyone wants to read that, or I can send you some of that. It took me a little while to figure out because I wasn't introduced to it that way when I learned it in school, but I saw it the other day, so I thought it was interesting to pass along. So anyway, that's a overview of how I would introduce algebra tiles if I was teaching 7th grade, I guess. And I absolutely love algebra tiles. I think that it really helps those students who just are not math oriented and they just need those visuals, they need those hands-on. Now, of course, you have kids who just hate them and they don't want to use them ever, and whatever, they don't have to use them. It's fine. But I think it just really makes a lot of concepts make more sense to the kids. So I really hope that you try to use them this year. Let me know how it goes. If you need any more support or any other help with them, I'd love to help you out, especially when you get to solving equations, because they come in handy with that as well. So again, let me know if you need anything.